Okay, this is section 3.3. Number one, people are having trouble with these, so I'm going to work through these here, try to do it carefully. So based on giving you information about a function, decide whether the function has a global max or a global min, neither, both, or it is not possible to say with the information. Assume that each function is twice differentiable and defined for all real numbers. So you can take the first derivative and the second derivative and define for all real numbers. In each case, write one sentence to explain your conclusion. Well, I'm not going to write the sentence, but I'm going to try to explain it so that you can write the sentence. F is a function such that the second derivative is less than 0 for every x, such that the curvature is concave down for every x. So that could look like that. That could look like that. Or it could look something like this or something like this. So do we know where there's the max? Well, it could be up here, or it could be at this end, or it could be at the middle someplace. So we don't know where the max is, and we don't know where the min is. It could be on the first side or the ending side, first side or the ending side. We don't know where the min is. Okay? But it's going to be on an end point. So that's all we know about it. It's got to have a minimum, global minimum on an end. Okay, now the second one. G is a function with two critical numbers, a and b. So if I were to make a graph of it, let's put this here. Two critical numbers, one is at a and one is at b. That's places where the derivative is equal to 0, since it's twice differentiable, no cusp, and all that kind of stuff. So we don't have any of those special cases. And A is less than B, so A is to the left, B is to the right. And I'm going to read this like I read it. The slope of G is negative for x less than a. So we've got a negative slope before a, so it's coming downhill. The slope is negative for x's between a and b. So it's still going downhill, but at a, it's a critical, so it has a slope of 0. So somehow it's coming down, slope of 0, and then it's going down some more. And it's going down, but then the slope is negative. And so even if it went like this, the slope is still negative until we get to B where it's 0. So negative slope, and then the slope is positive for x is larger than b. So over on this side, the slope is positive. So we know that there's a global min at b, but we don't know how positive it is. So the global max might be here, or this may get up past it by the time we get to the end of the interval and be more positive up there. So we know there's a global min at B for that one. C. H is a function with two critical numbers, a and b, and a is less than b. Same thing as we had last time to start with. And the slope of h is negative less than a. So it's still going downhill before a. It has to hit 0 at a for a slope because it's a critical number. Then the slope is greater than 0 between a and b, so it's positive, going up. Then it goes to 0 at b because it's a critical number. And then the slope is negative when x is greater than b. So beyond, it's negative. Okay. In addition, this curve approaches 0 when x gets really large. So this gets closer and closer to 0, and it gets closer and closer to 0 on this side. Well, if it's coming downhill and it gets closer to 0, it's going to have to be down here and then go up and then come down to approach 0 and to approach 0. So I had it too high here, so it has to get closer to 0 on this side and closer to 0 on this side, have negative slope up to A, 0 slope at A, positive slope to B, then negative slope and head towards 0. So if I got negative slope here, it has to be above. So I know that there's a global min at A and a global max at B. Okay, P is a function differential everywhere except at x equal A, and the curvature is it's concaved up for less than A and concave down after A. Differential everywhere except at A. So there's a point A where it's not differentiable. And it's concaved up before A. So that could come like this, or it could be coming like this, it could be coming, there's lots of different possibilities. And concaved down after A, which could look like this, or it could, if it went like this and then concave down, this would be differentiable. But if it was concaved up and then concave down, it could be a cusp there, concaved up, concave down. So with that, do we know where the minimum is? Well, this could come from any place and be concaved up, and this could be going to any place concave down. So we don't know where the minimum is. And do we know where the max is? Well, if it comes down like this, the max could be there. It's not over here, so the max could be over here at the beginning, or it could be, if it went like this and concave down, it could be at A. So we don't know much of anything. So not enough information to really tell. That's number one. Number two. This one gets a little bit messy. Each one of these takes a little bit of work. So we need to find P of 0 at one endpoint and P of A at the other end of the interval. And we need to find when P prime of x equals 0. So I have to take the derivative. And the derivative of this, x is the variable, a squared is just a constant, so it's minus a squared. Setting that equal to 0, we can add a squared to both sides. We can divide by the 3. And then we've got x squared equals a squared over 3. And we can take the square root of both sides, and we get x equals plus or minus the square root of a squared is a over the square root of 3. Okay. So we got to find P, and we have to be in this interval. And a is positive, so a over the square root of 3 is positive. And from 0 to a has to be positive numbers, so the negative one we don't have to do. So we got to do P of a over the square root of 3 and decide which one of these is the largest and which one's the smallest. If I put 0 in for the x's here, I get 0. 0 minus 0 times a squared is 0. If I put a into here, I get a cubed minus a cubed, which is 0. If I put a over the square root of 3 in here, that becomes a cubed over the square root of 3 times the square root of 3 times the square root of 3 is 3 square root of 3 minus a squared times a over the square root of 3. These don't have common denominators, so I'll multiply by 3, and I get a cubed minus 3a cubed, which is minus 2a cubed over 3 square root of 3. So, if a is a positive number, this is negative, and this is 0, and this is 0, so this is the min, and these, the max is, the absolute max is 0, and it happens at two different places, at 0 and a. That's 1. Now let's do 2. So, we've got r equals x, r of x equals a x times e to the negative bx. We've got to put in 1 over 2b into this. r of 1 over 2b would be a times 1 over 2b e to the minus b times 1 over 2b. The b's cancel, and so this becomes 1/2 a over b. There's a reason I'm writing it as 1/2 of a over b, and I'll explain soon. E to the b's cancel out, so this is negative 1/2 power, which is 1 over the square root of e. So we got 1/2 a over b, 1 over the square root of e. Okay. And r of the other end, which is 2 over b, would be a times 2 over b, in for the x, e to the minus b times 2 over b, which equals 2 times a over b. See, matching up, so I'm trying to make it look the same here. And e to the b's cancel and to the minus 2, which means we have 2 a over b times 1 over e squared. And then we have to take the derivative of this and set it equal to 0. So r prime of x, so this is a product, so I'm going to take the derivative of that, which is a, times this, plus the derivative of this, which is e to the minus bx, times the derivative of minus bx, which is minus b, times a, or the first, which was ax. There's e to the minus bx times a in both of these, so I'm going to go a e to the minus bx times 1 makes this, minus, let's see, there's an a minus, taking the a out, minus bx, and this I'm factoring out. So this equals 0 when 1 minus bx equals 0. This is never 0 if a is positive. And so if I add bx to both sides, and divide by b. And so now I have to find r of 1 over b. That's my critical value, and so if I put 1 in for the a and 1 over b in for the x, e to the minus b times 1 over b. The a times 1 over b is just a over b. E to the negative 1, which is a over b times 1 over e. Now, to determine which one of these is the largest, I have to see whether 1 over, since a over b is in all of these and they're both positive, b is greater than 1 and they're both positive, I have to decide whether 1 over 2 square root of e from the first one is larger or smaller than 2 times 1 over e squared, or 2 over e squared, or 1 over e. This is 1 over 2.7 approximately. This is 2 over 2.7 squared, which is 2.7. 2 squared is 4, 3 squared is 9, so this is probably about 8 approximately. And this is square root of 2.7 is about 1.5 times 2 is 1 over 3. So this is about 0.33. This is about 1/4 or 0.25, and this is 10 divided by 27 is about 0.4. So I think this one's the largest. This is a larger denominator, and this is a larger denominator, but with a 2 on it. This looks like the max, and this is probably the min. This is where the min is. This is the min, whatever this number works out to be. That's the min. It happened at b 2 over b. The max happened at the last one, 1 over b. It happened, and it's this, and all these are times a over b, whatever they are. So this one's someplace in between. This is a over b times this is the min, and a over b times this is the max. Let's do C. So we have to find W of B, W of 3B, and find the derivative and set it equal to 0 for the critical points. And A and B are both positive. So W of B would be A times 1 minus e to the minus b squared. Of 3b would be a times 1 minus e to the minus 3b squared. So minus b times 3b is minus 3b squared. And the critical, so we take the derivative. This is a constant, so it just stays, and we take the derivative of the inside, which is of a constant, which is 0, and the derivative of this is minus e to the minus bx times the derivative of the power times a minus b. And 1 is derivative is nothing, so that's it. This is a constant, so we don't have to do product rule on this one. So we get minus times minus is plus, a b e to the minus bx. We're setting that equal to 0, and it's never equal to 0, so we just have to decide which one of these is max and which one's min. Okay? Okay, and this one. This one's a little tricky to find all the places where the derivative is equal to 0. So, it's s of x is sine of kx, and k is a positive number. So s prime of x is k cosine kx. The derivative of sine is cosine of the same stuff times the derivative inside, which is x. And we're supposed to find out when that equals 0. So since k is positive, it's going to be when cosine of x is 0. And cosine is 0 at pi over 2. If you look at the unit circle, pi over 2, the x value is 0, and at 3 pi over 2, and 5 pi over 2, and 7 pi over 2, and minus pi over 2, and minus 3 pi over 2, and minus 5. Pi over 2 plus multiples of pi, going forward or backwards from 2 pi by a half a circle, pi, radians, we get that. And that is what the kx has to be to get 0 for the derivative. So if we divide by k, we get x, the actual x for the critical points will be 1 over k times pi over 2 plus multiples of pi over k. 1 over k times both parts. Now I could have said pi over 2k. So then we have to decide what angles are between 1 over 3k. So if I don't have this, I have pi over 2k. Is that between pi over 3k and 5 pi over 6k? So both of these have pi over k and pi over k, so it has to be between 1/3 and 5/6. This is 1/2, which is between 1/3 and 5/6. If I add pi over k to this, that would be 2/2, so it would be 3 pi over k over 2. 3/2, 1/2, this is pi, and we add a whole pi to a half of pi over k, we get 3/2 pi over k. And 3/2 is not between 1/3 and 5/6, so we don't want to go that way. And if we go down, subtract 2 pi over k, 2 pi over 2k from pi over 2. We subtract 2/2 from 1/2, we get minus 1/2, and that's not going to be between these. So we only have one other critical value, and we plug in sine of k times this x, pi over 3k, and the k's cancel, and sine of pi over 3 is 1/2. No, square root of 3 over 2. Pi over 3 is 60 degrees. The sine is the long one, square root of 3 over 2. If we plug in 5 pi over 6 times k over 6k, the k's cancel, and 5 pi over 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6 is here, and sine is positive 1/2. And if we plug in the critical value of k times pi over 2k, the k's cancel, and I'm getting the sine of pi over 2, which is 1. So square root of 3 over 2 is 0.866. This is 0.5. This is 1. So the max happens at the critical value, and it's 1, and the min happens at 5 at this end of the interval, and at 5 pi over 6k, and its value is 1/2. Okay.